Okay, so 1.5 and the title is So Creative, More on Identities. So we're just going to be using identities to write functions and other terms, like in terms of one function, just manipulating them. So write tangent in terms of sine. So I want tangent to equal only sine. Well, do we have a identity that involves tangent and sine?
Yes.
Which one?
Tangent equals sine over cosine.
So we know that tangent equals sine of theta divided by cosine. If I don't say theta, it's always there, right? Okay, so, but now we've got to get cosine in terms of sine also. So do we have a way to get cosine into sine?
Yeah.
With the what?
Pythagorean.
Pythagorean. So we have sine squared plus cosine squared equals 1, right?
Yes.
So then we would subtract sine and take the square root.
Yeah.
So then I have sine of theta over plus or minus. Why is it plus or minus? Because it's the square root. How do I decide on plus or minus? The quadrant. Good job. Okay, so did I write tangent in terms of sine?
Yeah.
Yeah. So if I had to find the tangent, I could do it just with sine. So you did a mini proof. Mini proof. Okay. So we're supposed to write secant tangent. So that means multiplied together, right? Because they're next to each other. In terms of sine and cosine. Probably can't see that. Oh, you can. Okay, so again, I'm just going to manipulate secant times tangent until I get in things, sines and cosines. Okay, so what do you know about secant tangent? How else could I write them? Oh, so when you do these, you always work down. You notice I line up my equal signs, that kind of stuff. So what do we know that secant tangent equals in terms of identities with sines and cosines?
Pythagorean theorem.
No. Because I'm trying to get secant tangent into sine and cosine. And the Pythagorean identity is just secant tangent. It's 1 plus tangent squared equals secant squared. So that doesn't have sine. Well, I could use it, but that we don't want to go there.
Tangent equals sine over cosine.
Tangent equals sine over cosine. What does secant equal?
Cosine?
Not specifically. It's cosine, but what about cosine?
It's
Yeah.
What is that?
Reciprocal.
Reciprocal. Yep. We're not going to use that word opposite. So we have 1 over cosine of theta times sine of theta over cosine. And we've discussed using parentheses, not dots or x's, yes?
yes.
Okay. Well, probably don't want to leave it just like that. So how could I simplify it? Can I squish it together? Can I multiply it? Yeah. So I'd have sine over cosine squared. So here I said sine and cosine, and I have it there, yes? But could I just say sine? So this is sine and cosine. So how would I get this just into sine?
multiply it by square.
Just get cosine out.
How?
Reciprocal.
Not the reciprocal. Use, what did we just use in the last one?
Pythagorean.
The Pythagorean, right? But this one we don't have to take the square root, do we?
No.
No, just 1 minus sine. So then I would have sine over 1 minus sine squared. So that would be just in sine. So can I do a lot of things with these?
Yes.
Yeah, and I'm just using those identities to manipulate it. That make sense what we're doing? We're not changing it, like we're not like eliminating functions or anything like that. We're just changing what it looks like. We're writing equivalent statements. How about that? Some words for you, right? Okay, so I want us to add one over sine plus 1 over cosine. How do you think we have to, what do you have to do?
Turn cosine into sine.
We could turn cosine into sine or sine into cosine. But in fraction, like we don't have to do that. Like in fractions, what do I do before I add or subtract them? I have to have what? Common denominators. So I could turn this into the square root of 1 minus sine squared, but that wouldn't be a common denominator, would it?
No.
No. So how would I get common denominators between sine and cosine? What if I had 1 over 6 plus 1 over 7? My common denominator would be 42 because they don't have any common factors, right? So I multiply them. So what am I going to do here? Multiply them. So my common denominator is going to be sine cosine. Correct? So what is the left going to turn into? What do I have to multiply it by? Cosine. And what do I have to multiply the right by?
Sine.
So it looked different, but did I do it any differently than I would have 1/7 and 6/7? No. And I think I've been trying to get you guys since geometry to get over that it looks funny, right? Right now in geometry, we're doing our trig ratios, and they're like, I don't know what to do. There's a square root. It doesn't matter if there's a square root. You just divide it, right? It doesn't matter what it looks like. You just do the algebra that you've been taught. Do the math that you've been taught. That's it. The book has like 15 other steps to this. I don't know why you would do that. Okay, well, if we got to add, I bet we've got to multiply, right?
Yeah.
Sine of theta plus 2 and sine of theta minus 5. Guys, you see binomial factors here, yes? If I can multiply, that means I also can factor. And we will. Okay, so what am I going to do with these two? How am I going to multiply them?
Factor.
No, they are factored. How am I going to multiply? FOIL. Distribute. That's all I'm going to do. So I'm going to have sine squared minus 5 sine. Then what?
So it's 2 sine minus 2.
And then I'm going to combine like terms, right? So I'm sine squared minus 3 sine minus 10. Guys, this is exactly the same as x squared minus 3x minus 10. What are the factors of 10 that have a difference of 3? 5 and 2. It's just not x squared, it's what? Sine squared. So it's sine and sine. Are we doing any math than you've been doing? No. just with a function. Are we going too fast?
No.
Awesome. Okay. Simplify. Square root of x squared plus 9 as much as possible when I want to write it how they write it in your problems in your textbook. After subbing in three tangent of theta for x. It's a lot of words when all they had to say is simplify when x equals 3 tangent of theta, right? Because that means I put in what? 3 tangent of theta right there. So that gives me the square root of 3 tangent theta what? Squared plus 9. Now you notice I didn't put the square right on the tangent yet. Why? What? You have to distribute to that 3, don't I? So I'm going to have the square root of 9 tangent squared plus 9. Say that again. Okay, how? Okay, close, but no. Okay, so this is a quantity, yes?
Yes.
And we can't take a square root of a quantity. We can take things, the square root of multiplication things, but not of quantities. So can we factor something out of that quantity?
No.
A 9. So then I have tangent squared plus 1. Okay. So now I have 9 times this quantity. Now can I take the square root of 9?
Yes.
Yes, because it's now multiplication. So the square root of 9 is 3. So we're going to be good there. But your, like, spidey senses should be going nuts right now. Why?
Because I'm Spider-Man.
Because you're Spider-Man? It could be factored into 2, but no, that one cannot. It's not difference of squares. Tangent squared plus 1. Tangent squared plus 1. It's one of the things. Which one of those things is it? It's a Pythagorean. So 1 plus tangent squared or tangent squared plus 1 equals what? Secant squared. Yes?
Yes.
Okay. So anytime I see a square, my spidey senses should be going off, right?
Yes.
And I should be going through those Pythagorean to see if it will work. Will it always work?
No.
No, but you need to be aware that they're there. So 1 plus tangent squared equals secant squared. Now, how can I remember that secant and tangent go together? Do you remember how I described it or how we found it? Remember, we're dividing by what variable's in the denominator of tangent? X. What variable's in the denominator secant? X. Or cosine, yes? So that's why they're paired. So we now have the square root of 9 secant squared. Now is it multiplication altogether? Yep. So what's the square root of 9? I didn't put my equals. is 3, and the square root of secant squared is
Secant.
secant. So you were close. You had the right idea, Savannah, but we just had to go about it the right way. So we're just learning to use those identities. It's going to give you more of an opportunity to learn them. Okay? Go through 51 today?
Yep.
I'm done.
That's it?
Yep.